Welcome back all my dear students. In today's video, I will teach you all about the error analysis. So whenever we are taking any measurement, there is a possibility that we do not get an exact answer. There is some sort of uncertainty in the measurement. This uncertainty in the measurement is what we call as error. For example, we are trying to measure the length of a wire. Okay, so now when we bought this wire from the market, we were told that it measures 5 meters. So now I come home and I use a measuring tape and try and measure the same quantity. Now when I measure it, the measurement comes out to be 4 meters. Now, since the true value, that was the expected value, is 5 meters, but when I measured it, I got a value of 4 meters. Therefore, I can say that there is a possibility that there is an error of 5 minus 4, that is 1 meter. So there is an error of 1 meter in my measured value. Now, errors arise from different sources, but there are two main types of errors that we will try and understand today. So there is systematic error and there is random error. Let us try to understand the systematic errors, and under systematic errors, the first one that we come across is the instrumental error. Instrumental errors, they arise due to the imperfect design or wear and tear of the instrument. They can be like the zero error, which is basically coming in when the zero is worn out or the zero is not visible due to various reasons. It could be due to wear and tear. So the zero is not visible in zero error. Then there is another type of instrumental error, which is the least count error. In every instrument, every device that we use has a particular least count. Now, if you're trying to measure some values which are less than the least count of the instrument, then the least count error would occur, because then your device cannot measure those values with complete accuracy. The instrumental errors can be reduced by using more accurate instruments and applying zero correction whenever required. Now further, we move on to the random errors. Now these errors occur irregularly and at random. You cannot anticipate these errors beforehand. That's why they are called random errors. So they can be due to the voltage fluctuation or a temperature fluctuation or some pressure fluctuation. The only way to minimize random errors is by repeating the observations a large number of times and simply taking the arithmetic mean of all those observations. This is the only way to reduce random errors. Now, since we know about the different types of errors that can arise, we will try and understand how to measure these values, how to measure the errors. One way that we figured out was that we subtract the true value and the measured value and we get the uncertainty in our measurement. But there are some particular ways in which we can calculate the errors. So these ways are, to start with, let's understand what is absolute error. The difference between the true value and the measured value of a quantity is called the absolute error. That's the error that we calculated earlier also. Now, let us try and understand this in slight more detail. So let's say that we took, I measured certain values. I measured some values of a wire, let's say, or a length, which I got as A1, A2, A3 and so on up to AN. Okay, now usually the mean value is taken as the true value. So I will have to measure the true value, or I'll have to figure out the mean value, which is going to be equal to A1 plus A2 plus A3 plus AN, and then I will have to divide it by the number of the quantities. So by doing this, I can calculate the absolute error by subtracting this mean value and the measured value, because the mean value we are taking as the true value, right? So if I want to find out the absolute error in A1, then for that I will have to subtract A1 from the mean value, which I am assuming to be my true value. If I want to measure the absolute error in A2, then I'll have to do A2 minus the mean value again. Every time we are only taking in the magnitude, because errors can only be added, errors can never be subtracted. Now once I get the absolute errors, I can also find out the mean absolute error by simply taking the average of all the absolute errors. So suppose if I have only two measured quantities, then I can have the mean absolute error of delta A1 and delta A2. All I do is that I take the mean absolute error as delta A1 plus delta A2 divided by 2. So that will give me the mean absolute error. Now we also define something known as the relative error, which is the ratio of the mean absolute error to the mean value of the quantity. Now if I want to calculate the relative error, then that would be equal to the delta A, which is my mean absolute error, divided by A mean, which is the mean value of the quantities measured. I can also find out the percentage error from it. To find out the percentage error, all that I have to do is I have to multiply the relative error by 100. So relative error multiplied by 100 gives me the percentage error. So in short, the percentage error would be delta A mean by A mean times 100. Now, since we understood about the absolute error, the relative error and the percentage error, therefore let us try calculating some errors by applying all these three formulae. So the length of a rod as measured in an experiment is found to be 2.48 meters, 2.46 meters, 2.49, 2.49 and 2.46 meters. You have to find the average length and the absolute error in each observation and also the percentage error. So the first thing that I will have to do is I will have to measure A mean. To find out A mean, I take the average of 2.48 plus 2.46 plus 2.49, another 2.49 and 2.46, and because I have a total of 5 observations, therefore I divide all of these by 5. Now when I divide them by 5, I get a value of 2.48 meters. Now this is my mean value, okay? Now I have to find the absolute error in each of these. To find the absolute error in delta A1, then I will have to do 2.48 minus 2.48. So the error that I get in the quantity A1, the absolute error that I get over here is actually 0. Similarly, I can find the absolute error in A2, which would simply be equal to 2.46 minus 2.48. So that gives me an absolute error of 0.02. Similarly, I can find out the absolute error in A3, that is 0.01. Absolute error in A4 is also 0.01 and absolute error in A5 is 0.02. Now I can take the mean of all these absolute errors, which simply comes out to be 0.01. Further, to find out the percentage error over here, I will have to do the mean absolute error divided by the mean value, which I got as 2.48 times 100. So what I'm doing now is 0.01 divided by 2.48 times 100, and I get the percentage error in this measurement as 0.4%. Okay, I hope you understand. So we have calculated the absolute error, the mean absolute error, the relative error and the percentage error in this particular question. Now let us try to understand how to combine these errors. Okay, so let's say that I want to add or subtract two quantities. When you add or subtract two quantities, the maximum absolute error is the sum or the difference of the two quantities. That would be like the maximum absolute error in sum or the difference of the two quantities will be equal to the sum of the absolute error in the individual quantities. Let's say I have a quantity A plus minus delta A and a quantity B plus minus delta B, and I want to calculate a quantity Z, which is A plus B. Now, if I want to calculate the absolute error in Z, then that will be equal to delta A plus delta B. Even if I was to subtract the quantity A minus B, then also the error in delta Z would be delta A plus delta B only. The errors are always supposed to be added, irrespective of the fact whether you are subtracting or adding the two quantities. Now, for the multiplication and the division rule, the maximum fractional error in multiplication or division of the two quantities is equal to the sum of the relative errors in the individual quantities. So now over here, let's say again I have the quantity A plus minus delta A and B plus minus delta B. Suppose I define a quantity which is Z equal to A multiplied by B, or even if I define A divided by B, in both situations my delta Z, that means the fractional error in Z, that would be equal to delta Z by Z, will be equal to delta A by A plus delta B by B. So the relative errors in A and B have to be added when I'm multiplying or dividing A and B. Again, even if you divide, even if you multiply, in both situations we are always adding the relative errors. We cannot subtract the relative errors. Fine. Let's move on to the power rule. Suppose we define a quantity z which is equal to a to the power n. Now, if I want to find out the fractional error in z, then that would be equal to n times the fractional error in a. Whatever is the power, that has to be multiplied with the fractional error, and then only you will get the total fractional error in the quantity. So delta z by z would be equal to n times delta a by a. The power is always multiplied. This is a very important concept because this has been asked in the NEET exam every now and then. So a question based on power rule can be expected in the NEET 2026 exam as well. Since we have understood all the rules that apply to errors, let us start working on the PYQs. So I have a NEET PYQ which was there in 2019. It says that in an experiment, the percentage of error occurred in the measurement of physical quantities A, B, C and D are 1%, 2%, 3% and 4% respectively. Then the maximum percentage of error in the measurement of X will be. So they have told us that X in this situation is equal to A cube B to the power 1 by 2, C to the power 1 by 3 and D to the power 3. So now when I want to find out the fractional error in X, or if I want to find out the percentage error in X, we will use the power rule. The percentage error in X will be 2 times the percentage error in A plus half times the percentage error in B plus 1/3 times the percentage error in C plus 3 times the percentage error in D. So the powers are just being multiplied by the percentage errors and we are going to add all of them. The only thing to be kept in mind is that whether the quantity is in the numerator or the denominator, the power always has to be multiplied with the percentage error. Therefore, the percentage error in X will be equal to 2 times 1 plus half times 2 plus 1/3 of 3 plus 3 into 4. The total percentage error from here comes out to be 16%. So my answer over here is 16%. I hope you understood how easy the question was. Only one very basic rule, the power rule, had to be applied here. Now let us move on to another NEET PYQ. This is from NEET 2023. It says the errors in the measurement which arise due to unpredictable fluctuations in temperature and voltage are. The key word here is unpredictable fluctuations. Whenever it's unpredictable, something that you cannot anticipate beforehand, we will call it a random error. So the answer directly over here is a random error. It's not a personal error, it's not a least count error, it's just a random error that is arising. Further, it was an easy question and a straightforward question. Let us move on to the next question, which is from NEET 2025. It says a physical quantity P is related to 4 observations A, B, C and D as follows. The percentage errors of measured of measurement in A, B, C, and D are 1%, 3%, 2%, and 4% respectively, the percentage error in the quantity P is. Again, it's a question on power rule. So from here, we can very easily say that the percentage error in P will be equal to 3 times the percentage error in A plus 2 times the percentage error in B plus 1 time the percentage error in C and half times the percentage error in D. You can see that D is under the square root. Square root means half. So the percentage error in D has to be multiplied by half, as half is its power. So the total percentage error in P will be 3 times 1 plus 2 times 3 plus 1 times 2 plus half times 4. If I add all of these, I get a total of 13%. So it's a very easy question, and 13% is my answer here as expected. I have covered almost all concepts that were related to error analysis and done the PYQs. If you wish to download these notes, the link is available in the description. Thank you for watching, and don't forget to subscribe to my channel.